Welcome back to College Algebra videos. This is the third video for graphing logarithmic functions and finding their domains. So again, objectives and goals, you know already. But in this specific video, what we'd like to do is determine the domain of logarithmic functions algebraically. So I'd like to give you one small reminder and then we'll start computing some of these domains. Number one, remember that when you're looking at the graph of A, and this is supposed to be a base. So right here, let me actually delete something. This is supposed to be log little base a x. Okay, so sorry, the font didn't transfer over correctly, but that's what it's supposed to look like. That's our f of x. If you have a function that looks like this, what we determined last time is that there's 2 points that are really important. If the input is a, so let me write here. If the input is a, we know the output is 1. And if the input is 1, we know the output is 0. So we'll always have those 2 points. And then when we graph it, we know that there's an asymptote right here at x equals 0. So that's the asymptote, x equals 0. It's called the vertical asymptote. And we did this a couple of weeks. You actually spent some time graphing these. And you notice that they were related to the exponentials. So now what we're going to do is we're actually just going to graph this, and this goes like this. So this is something that you definitely know already, that this is what the shape sort of looks like. Now the other thing I wanted you to know is that the domain, if you remember, you guys said that the domain was from 0, but we don't include 0 because of the asymptote to infinity. And the range is from negative infinity to infinity. Now, I want to focus on domain. The goal here is to be able to find the domain in an algebraic way. And so I want you to, this is the big idea that I've been trying to get across when we solve inequalities. That this notation from 0 to infinity, this is interval notation. So I want you to translate that into algebraic notation. And this means that x should be a number. So notice the number. So this interval notation means that the domain is any number between 0 and infinity, but not 0. Not 0. It has to be bigger than 0. And so to translate that, we say this. This is another way to think the domain. It's all the numbers that are bigger than 0. In other words, we say all positive numbers. So that's another way to say this, is to say all positive numbers. And for any exponential that looks like the one I just graphed, that will always be the domain. Now, in general, what this means is the following. I'm going to give you some really interesting expressions. Interesting means maybe difficult. For example, I'll give you something like f of x equals the log, I don't know, base 3 of maybe x squared plus 2x plus 3. And when I want to find the domain, we have this input here, this expression, and from this observation that I have up here, that the domain is all numbers that are greater than 0. Oops, sorry. The fact that the domain is all numbers that are greater than 0 right here, this is the observation. What we're going to do is we're going to say, oh, okay, well, let's take this x squared plus 2x plus 3 and make it greater than 0. But wait a minute, you guys have done this. This was on the last exam. It was one of the difficult questions, something that we struggled with, that is something that you will need to learn because I do need you to make sure that you're able to do this. So let's do some examples so that you can see. So first of all, we'll do the easy examples. Here are these functions. F of x is log 5 of x. We want the domain. So let me write it over here. So what you need to do is take the input, this, and make it bigger than 0. And solve. Oh, we're done. Okay, so the domain, 2 ways to write it. I'll let you decide which one you want to use. You can say x is greater than 0, or you can say from 0 to infinity. These would both be acceptable. Alright, what about g? So for g, again, we look at the inside. This is the expression. And we know from our conversation that that means that I need to solve the following. X plus 1 is greater than 0. Well, that's not too bad. All I do is subtract 1 on both sides. And so I get that x is greater than negative 1. So the domain, 2 ways to say this one, x is greater than negative 1 or negative 1 to infinity. All right. That's easy too. So let's go ahead and do this last one. If you want, you can pause the video now and see if you can get the answer, and then come back and watch and see if you got the right one. Okay, from our discussion, this is the expression. We want this to be greater than 0. So now I solve. Add 1 to both sides. So now I want x to be greater than 1. So the domain is x, all numbers that are greater than 1. Or if you want, you can write it in interval notation, 1 to infinity. Now, I make a big deal of interval notation because in calculus, interval notation is used quite a bit. But it's actually very good for you to know both notations and be comfortable with both and be able to translate one and the other. That's even more, probably more important than just knowing interval notation. All right, now let's go to some examples that are just slightly more interesting. All right, here we go. We want to determine the domain of this function. We don't want to graph this function. We could. It would take some time, but we would like to spend our time doing something else. And so let's go ahead and start graphing this. So we know from our conversation that this input, all of this, in order to find the domain, we have to make it greater than 0. We have to solve this inequality. Hopefully you remember how to solve this inequality in your last test, but I'll review it right now. Your first step is to the following. Let's find critical numbers. Find critical numbers. And the way you do this is by setting the top equal to 0, x minus 1 is equal to 0, solving x equals 1, and then setting the bottom equal to 0, solving x equals negative 3. Now, because the negative 3 is in the because the x plus 3 is in the denominator, we know that this is an open circle. You can't plug in negative 3 back into here. You can't plug in negative 3 back into there because you can get 0 at the bottom, so it's going to be an open circle. Now this x equals 1, though, we have to decide if it's in the open circle or not. And so what we've done in class is we plug it back in and we find out. We say, okay, well, let's try 1. And then we go ahead and subtract 1. Let's plug in 1. And then we add 3. And we ask ourselves, is this bigger than 0? And so when we work it out, we see that 1 minus 1 is 0. 0 over 4 is 0. Is 0 greater than 0? And the answer is no. So that means open circle. That means open circle. And so if you remember, what we do next is we go ahead and make a number line. We go ahead and make a number line like this. We graph our critical points, which are, I forgot what they were, which are 1 and negative 3. So negative 3 is maybe over here. 1's over here. We have open circles at both of those points. So let me make those in red. Open circle here and here. And then we have to solve the inequality, which we know is, we had already written as x minus 1 over x plus 3 is greater than 0. And so what we've done so far is we've said, okay, pick a number here, maybe negative 10, pick a number here, maybe 0, pick a number here, x equals 10. And the intervals that we're interested in are the intervals from negative infinity to negative 3, parentheses because of the open circle, negative 3 to 1, parentheses because they're both open circles, and 1 to infinity. And we have to determine which of these works. And so when you plug in the numbers, the values, when I plug in negative 10, so I get negative 10 minus 1 over negative 10 plus 3. I'm trying to see if that's greater than 0. In the numerator, I get negative 11. In the denominator, I get negative 7. But a negative divided by a negative is a positive. And this really is greater than 0. So yes, this is an interval we keep. We will keep this one. When you plug in 0, 0 minus 1 over 0 plus 3, we're trying to determine if it's greater than 0. Well, in the numerator, I get negative 1, the denominator, I get 3, but a negative number can never be bigger than 0, so this is not true. This is false. So we don't keep this interval. And finally, we plug in 10, so 10 minus 1 So we plug in 10 minus 1, so 10 minus 1 divided by 10 plus 3, and we try to determine if this is greater than 0. Well, 10 minus 1 is 9, and 10 plus 3 is 13, and this is a positive number, and positive numbers are greater than 0. This is true. And so since it's true, then this is the interval. And so all this work, I want you to remember that all this work, the goal was to determine the domain of the function. That was what we wanted to determine. What is the domain of this function? Well, now we know what intervals to pick. They've been marked. So you would answer the following. You would say that the domain is from all the numbers between negative infinity and negative 3, and union the numbers from 1 through infinity. These would be the domain for this particular function, and this is how you would do it. And so this is why I wanted you to learn how to solve inequalities. Now I'm going to go ahead and click to the next example. I'm going to ask you to try to solve it on your own, and in the next video we will solve that one and the one after that. Here would be our next example. See if you can find the domain of this function. Watch the next video for the answer.